give you some hints on doing this activity right here that we have on the shift registers. And we're going to look right here when we start working on this part. We need to input this sequence into this once we have this in multisim. And I have a couple of switches over here in order to do that. So what I need to do is look at one of these flip-flops individually, and I need to figure out where these switches are going. Well, if you follow this switch here, this one goes to, on each one, the clock. This switch right here is setting up the clock on all four of these. This other switch here is going to J, and it has an inverter that's going to K. So whatever this one is, this switch is directly tied into J, and K is always going to be the opposite. So let's go back and review what we had when we looked at this activity a couple of activities ago. We literally did this one so we were ready for what we're doing now. We did this one, and we did this part right here, number 2, on this JK flip-flop. This is exactly the flip-flops we see here. This is exactly the same one. And here, what we did here on this part right here was exactly setting up what we need to do to get this sequence entered here. So let's first go back and review what we had. We just said here, this is going to mean that J and K are always opposite. So we're talking about these two categories here, 0, 1 or 1, 0, because these are always opposites. And what we have is anytime it's got the two different ones here and here, Q is always the same as J. So it doesn't even matter K in these cases. Whatever my switch is here is going to be what my output of Q is on this side. So let's just look through how this actually works on a graph. So what I'm looking at is I need to set up Q to be the sequence 1, 1, 0, 1. This is the output I need. And this is just like the one on the first activity we did with the little grass. We're looking at the rising action. Or we're looking at the falling action. This one right here I have marked. So right here, J, if I want Q to be 1, I need J to be 1 at this point. And that'll mean that Q is also 1. The first time the clock goes from 1 to 0. Then when I flip back, it's not going to make any difference. When I flip back the clock back to 1, it's not going to make any difference until I go to 0 again. And at this point, I also want a 1 inputted. Or I want a 1 outputted, so I want a 1 inputted. Then, again, when I flip back to 0, when I flip back to 1, not making a difference. Until I again flip the bottom switch to 0. And here I want my Q to be 0 at this point. So at that point, sometime before I flip this clock switch, I need to have switched the input J down to 0. So that at this point when my clock hits, it's going to read 0. Then, flip it back to 1, doesn't matter until I go to 0 again. When I hit 0 again here, I want my output to be 1 at that point. So at some point before I get to this clock switch, I need to have switched back to a 1 so that I'm at 1 when I hit my clock. This is basically the idea of how you're going to input this here using this switch, which is your clock, and this switch here, which is your J. When you get this part done, I want to check that this does in fact give you a D up here in the corner. Then it says now go back and modify this circuit to see so that this is the sequence that's going to get you the D. So what I want you to do is when you get this part done, call me over and I'm going to check it that it does, and I'm going to stamp it. And then when you get this part done, call me over and I'm going to stamp it that it works on this part. Then you're going to go to PLD mode. PLD mode. You're going to remake your circuit in PLD mode. Run the simulation here. I don't need to see these simulations because in PLD mode, I'm going to wait till you actually get it set up on your digital logic board. Be sure you're following the instructions as you set it up, And when you get your digital logic board working, then call me over. That's it.